Hi, welcome to video 8.7b part 1, another indeterminate form, 0 times infinity.
We'd all agree that if you take a large positive number and add to it another large positive number, you'll get an even larger positive number. So everybody should agree with infinity plus infinity is infinity. If you take a large positive number and multiply it by a large positive number, you'll get a large positive number. If you have, say, negative 5 million minus 7 million, you'll get negative 12 million. If you have a positive real number c, like 3 times a million, you'll get 3 million. Negative 3 times a million, you'll get negative 3 million. 3 million plus 3, you'll get 3 million and 3, still infinity. 3 million minus 3, 2,999,997. So again, that will give negative infinity. So that should be pretty straightforward. However, infinity minus infinity is an indeterminate form. It is not 0. And the reason it's not 0 is because, remember, infinity is not a specific number. It's just a concept of a very large number. So, for example, it could be 20 million minus 10 million, which is 10 million. On the other hand, it could be 10 million minus 20 million, so the answer is negative 10 million. On the other hand, it could be 10 million and 2 minus 10 million, which would give 2. As you can see, very different answers. It's very hard to determine what the answer would be, hence they're called indeterminate forms. So, the two we're going to look at, as we said today, are 0 times infinity and infinity minus infinity. Now again, we talked about infinity minus infinity already and why that's indeterminate. 0 times infinity, keep in mind we are looking at limits, so it's really not 0, it's a number close to 0 multiplied by a very large number. Well, that number close to 0 could either be a positive number close to 0 or it could be a negative number close to 0, and hence we would end up with two very different answers. So, how do we deal with 0 times infinity? Well, we use what we call as the reciprocal. If you look at it, do you not agree that a times b is the same as a divided by 1 over b? Because if I multiply by the reciprocal of the denominator, I'll get a times b. So what we're saying is you can change a product into a quotient. You leave one of the factors on the top. Here I left the a, here I left the b, and you then divide by 1 over the other factor. Now, the reason this is going to work out so well is, for example, if we leave the first factor as the numerator, and then we, instead of saying times infinity, we divide by 1 over infinity, then that 1 over infinity will become 0, and you'll be able to you'll have L'Hopital's because you'll have 0 over 0. If, on the other hand, you leave the second factor on the top, and you take the first factor, instead of times 0, right, divided by 1 over 0, again, 1 over 0 will either be infinity or negative infinity. Remember, that's a non-zero over 0. And infinity over plus or minus infinity will allow us to use L'Hopital's. Okay? So, here's an example, number 46. What's the limit as x approaches 0 from the right of x cubed cotan x? Well, as far as cotan x itself, when you're going to substitute, you've got 0 cubed is 0. The limit as x approaches 0 from the right of cotan x. This is the graph of cotan x, so the limit as x approaches 0 from the right would be positive infinity. So we have that special indeterminate form. And what's going to happen is we're going to go from that form to either 0 over 0 or infinity over infinity, allowing us to use L'Hopital's. So I'm going to leave the x cubed on the top. And instead of times cotan, I'm going to divide by 1 over cotan. So I'm using the reciprocal. Then I'm going to rewrite 1 over cotan as tan itself. And now I'm going to substitute, and I'm going to get 0 over the tan of 0 is 0. I now can use L'Hopital's. That was the whole point of doing what we did. I'll plug it in, and I'll get 3 times 0 squared plus 1 squared. Over 1 squared, which will be 0 over 1 or 0. Now, I strongly emphasize, once you have done this reciprocal thing, and same thing with the L'Hopital's, simplify that expression before you substitute. Because if you substitute right now, all that's going to happen is you're going to have 0 over 1 over infinity, and you'll end up with 0 over 0, which is the same thing I got here. But then the problem is when you go to use L'Hopital's, you'll have this fraction here and that'll cause severe havoc. So you don't want to do that.